Hello grade 5, 6. I'm pretty sure you're going to enjoy today's lesson because we're talking about fire today, and let's face it, we all just find it really fascinating. It's quite an interesting kind of reaction, and probably you don't know a whole lot about how it actually works. So, just so you know, fire and burning is actually a type of oxidation reaction, which we looked at last week. So similar to things like rusting and corroding, but also not similar at all. But what happens is oxygen reacts with something, and the reaction happens so fast that a huge amount of heat and light is released. And that heat and light is energy, and we see it in the form of fire when we have fires. The actual word that we use to describe this in chemistry is combustion. And a combustion reaction is one where oxygen reacts with something really quickly, producing lots of heat, and then out at the other side, you get water and carbon dioxide. Fire is a huge thing. There's lots of things that make fires, lots of different fuels that you can burn for that. But I want to start just by showing you a stovetop. A lot of you probably have gas stoves at your house, and the way they work is that gas comes out from the stovetop itself when you turn that knob, and then you ignite it by adding some heat to it, and that catches on fire. Now you might notice that fire on your stovetop doesn't really produce much smoke. So you don't end up with a house full of smoke every time you put your stove on, unless you're cooking and you boil things the wrong way or whatever. But generally, you just get this really nice pure fire, sometimes blue, sometimes a little bit orange, and you don't get much smoke. Now this is because it's complete combustion. That means there's enough oxygen in the air to react with that gas really quickly, produce fire, and nothing else is made other than water and carbon dioxide and the heat.
When you look at a burner, there's often a little bit on top that you can pull off. And underneath there, you'll see a little ignition part, which I'm pointing to here. Now, when I press the ignition button on my stove, this little thing makes a spark. If you have a look closely at the video, I've slowed it down. You can see tiny little sparks, which look a bit like lightning, actually. Now, this produces the heat, which then catches onto the gas and makes the fire start. So I'm just putting my stove back together, and in a minute you'll see the fire start as that little spark catches onto the gas. And there it is. Now at the start you see a little bit of an orange flame, but a clean burn has a very blue flame, and you can see now it's kind of going more that blue colour. This means that there's no extra little bits being produced, there's no smoke, no carbon, just pure carbon dioxide, water, and then all the heat that comes out of that fire. Okay, so the reaction of combustion is pretty easy to understand, actually. At the moment I'm doing the one that is on my stovetop. So methane is just one carbon with 4 hydrogens, and that mixes with oxygen atoms, which hopefully by now you know are 2 little oxygens attached together. And these two things with heat burn, and you end up with water, which is H2O, and carbon dioxide, which is 1 carbon with 2 little oxygens. Now, this reaction produces a lot of heat and light, which is our fire. Now, looking at this reaction, you might be able to see that the number of methane molecules and oxygen doesn't really match up with what's on the other side. And so actually what's happening in this reaction, if you want to make it a balanced equation, is that 2 oxygen molecules react with a methane molecule to make 2 waters and 1 carbon dioxide.
Now here I'm just going to burn a candle and put a jar on top so you can see the water is being produced. I showed you the reaction and I told you that there's carbon dioxide and water, but you can actually see the water droplets that form on the inside of a jar when a candle burns. Now when fire doesn't have a full reaction happens, so there's not enough oxygen for all of the fuel, you get carbon dioxide coming out the end, and you get water coming out the end, just like on your stove, but you also get other bits and pieces coming out made of carbon, the extra little bits of carbon that are floating around. Sometimes it looks like that coal-y kind of charcoal-y stuff in the bottom of your fire. Sometimes it might look like black smoke coming up. And this is all the kind of extra little bits that can't really react with the oxygen. When you burn a candle, this is another type of fire. Wax is another thing that has lots of carbon in it and hydrogen in it, and these mix up with the oxygen, and then again you get the water and the carbon dioxide. You're gonna love this one. Okay, here we are for... I never remember what the second one's called.
Is it funny?
Is it funny to a teenager? This is my teenager, Abby, and I'm going to show her a cartoon that I found. This one's hilarious. And if Abby thinks it's funny, she holds up the smiley faces and then you get to see it. If she thinks it's a bad joke, she'll hold up these two and you will never get to see the joke. Okay, Abby, are you ready?
I'm ready. I win.
You did a big, huge laugh. You've got to pick this one. Okay, Abby picks this one. I'm pretty
Sorry
sure.
guys, I'm picking this one. It was good, but...
Oh, okay. All right, we still get to show it. So
Yeah.
you get to see it next. All right, thanks, Ab. Now, you might or might not have heard of a thing called the fire triangle, and this kind of explains the three things that fire needs to get going. So if you don't have one of these three things, you won't have fire. And if you've got a fire and you can take away one of these three things, then you'll be able to put out the fire. So I've got a little picture here. All right, this is my fire triangle for you. So the first thing you need for fire, and this is pretty obvious, right, is some type of fuel. Now, in a car, the fuel might be petrol. In your stovetop, the fuel might be methane gas. In your fireplace, the fuel is going to be something like wood and newspaper. If you're lighting a candle, then the fuel is going to be the wax in the candle. So there's lots of different things that can burn, and if you can get the right fuel, then you can have a fire. Also, if you can take away the fuel, you can stop the fire. All right, the next thing you need is oxygen. You can't have a fire without oxygen. So I guess that means you couldn't light a fire in space. I never really thought about that. Okay, fuel, oxygen. Without oxygen, oxidation can't happen, your combustion reaction can't happen, you can't set something on fire. So you have to have oxygen. Also, if you can take oxygen away from a fire, then you'll be able to put it out. Okay, and the third thing is heat. So it's not like, you know, I'm sitting here with a piece of wood on the floor and there's oxygen all around me and suddenly there's a fire. That doesn't happen. You have to start the fire with something, and that something is heat. Now, usually when we start a fire, we start it by making heat. Either, if you've ever used a match on a matchbox and you go, and it actually, that friction makes heat. Just like rubbing your hands together makes heat. On your stovetop, there might be a little button that you press down, an ignition switch, and it goes flick, flick, and you see like these little sparks coming out. That's producing heat, which then sets that gas on fire. So you need the oxygen, you need heat, and you need a fuel for a fire. Now, today we're going to have a little bit of a look at what happens if you can remove some of those things. So what if I remove the oxygen? What if I remove the heat? What if I remove the fuel? Will I see that fire go out? And this is what firefighters learn. When they go and learn how to be a firefighter, they learn about these three things and how you can reduce the impacts of them. All right, so let me show you a couple of little experiments now.
Okay, so here I have 2 candles and I'm just lighting both of those, and we're going to take away one of the 3 things that fires need to burn. The first thing I'm going to take away is oxygen, and you can do this in a couple of different ways. The first is by putting a glass on top of the candle. Now this blocks out all the oxygen that's in the air of the room, but there's still a little bit in the glass. As that oxygen runs out inside the glass, the candle goes out before the other one. You can also get rid of the oxygen by blowing on the candle. Now, the second thing we're going to remove is the heat. And to get rid of heat, you might know this, you can either blow on it and make it cooler, or you can drop water on it, which cools it down as well. Last week on Science Adventures in Legoland. "430 Whitehorse students radioed in to help Danielle and Sunny solve the mystery of why food goes off over time. These were some of the responses. Sunny and Danielle decided to go back and visit the man in the juice bar and ask him some questions about his fruit. "Excuse me, juice man, we've been wondering why all your fruit looks so fresh when the banana in my school bag looked really black and fluffy."
Ah, well, all this fruit is very fresh. We have to buy it in every second day.
But what happens if you don't buy it in every second day?
Well, we have had the same problem as you, that the fruit starts to change colour and smell a bit funny, and sometimes stuff starts growing on them.
Does that happen to all fruit?
Oh yeah, mate, most fruit.
Do you know what it is that grows on them?
Yeah, do mate. You may not realise that tiny little bacteria and fungi live all over fruits and vegetables. They are so small that you can't see them. These tiny creatures are extremely good at breaking things down. After a fruit or vegetable is picked, the bacteria and fungi start to grow, eating the food and making it break down.
Is that what the fluffy stuff is?
Yeah, mate. The fluffy stuff is usually fungi, and the shiny slimy bits are usually bacteria.
Is there any way to stop it?
Well, once the fruit is ripe and ready, you can put it in the fridge, which slows down the bacteria and fungi. But it won't stop them forever, mate. Eventually, all living things break down.
That's very helpful, thank you. Do you know if other food breaks down too?
Well, you might need to go and ask the cafe lady next door about that. She has other types of food over there, mate.
Sunny and Danielle made their way back to the cafe again. Sunny was eyeing off sandwiches on the top counter, while Danielle asked the lady about other types of food.
Hello again. Do you happen to know of any foods that don't go off or grow bacteria and fungi?
Well, we have lots of baking supplies here, and things like sugar and salt almost never go off. You can keep them for years in the cupboard and they are still good to use. Also, other things like jam and chutneys have lots of sugar in them, so they last a really long time. And then there are the dried out things like rice and dried peas and things which don't go off as easily because bacteria and fungi like to grow on more wet things. Maybe if I dry out my banana, it will be okay?
Sunny, I think that banana is well beyond being okay.
Oh, what about my muffin?
That too, Sunny.
And with that, the mystery was solved. Did you guess why food goes off over time?
Okay, today I want to tell you a story about two birds that are not usually friends. In fact, these species of birds are usually enemies. So, I've drawn some pictures for you today. One of the birds is a red-tailed hawk that looks not very much like that in real life. And the other one looks exactly like this, a bald eagle. Now, bald eagles are much bigger than red-tailed hawks. Bald eagles generally, they live near the ocean, they generally eat fish, seafoody kind of things. Whereas red-tailed hawks, they usually eat rodents, which are mice and rats and those sort of things, little birds and stuff like that. But Eagles are known to be a bit opportunistic, which means that if they see something else that looks tasty, they'll just take it and eat it if they can. So here's a picture to help you remember this, okay? Bald eagles eat fish usually. Hawks usually eat mice and rats. Okay, so there was some footage taken a couple of years ago. You can still find it on the internet. I love this. I might have even told some of you about this. There is a nest of a bald eagle at the top of a tree. And in that nest, it has 3 babies, I think, of its own, which are almost as big as it. So they're huge birds, okay? This one and its babies. But then in the nest also is a tiny bird, which is a chick and fluffy. And it was one of these, a red-tailed hawk, in the nest of this one. And this bald eagle was feeding it and bringing it up as if it was its own baby, like it hadn't actually noticed that it was bringing up 3 enormous birds and then there's one little titchy one in there as well. And it turned, well, actually no one really knows how it got there. Some people suggested that maybe a hawk came and laid an egg in the eagle's nest when the eagle wasn't looking or something. I don't know if that could be true, but most people have suggested that the way that the red-tailed hawk got in there was that maybe the eagle had actually grabbed it from another nest as food for its babies. And then when it had brought it back to its nest, and it was living now with these guys, it started calling for food and opening its mouth and wanting food. And then perhaps, we don't really know, but they think that the bald eagle started feeding it and then treating it like it was its own baby, accidentally forgetting that it was meant to be eating it instead. So anyway, this little red-tailed hawk grows up in a family of bald eagles. Adoption at its very best, right? And what's funny is that as time went on, it's a bit sad because these eagles kind of go off and become solitary, go far away, and the red-tailed hawk would probably stay in the area. But it turned out that the red-tailed hawk was starting to eat fish, and so there was these videos of it eating fish, which is what these guys eat. So even though it's a hawk, it had sort of learnt some behaviours from its adopted family, which is really interesting. Often animals, if they grow up in different families, they actually still have their own behaviours that they were born with, I suppose, from their parents. So it's a really interesting story about 2 birds that should be enemies ended up being in the same family.